strength of approximately 96 to 98%. In case of 98%, it means 980 ml of H2SO4 is present per 1000 ml of concentrated acid solution. It means 980 ml of H2SO4 is present per 1000 ml of concentrated acid solution. Generally, the H2SO4 which is available in labs is of strength of 98%. So we can go by that calculation. Let's follow the following steps to calculate the volume of concentrated required to prepare 1 normal of H2SO4. Step 1. First of all, calculate the weight of H2SO4 in 980 ml of H2SO4 by multiplying it with specific gravity. Generally, if you require to calculate the weight of any liquid, then you have to multiply it with its specific gravity. In that case, we have specific gravity of concentrated H2SO4 is equal to 1.84 and we need to calculate the weight of 980 ml of H2SO4 in 1 liter of solution. Here we go with the calculation and we get the value of 1803.2 grams. It means 980 ml of H2SO4 which is present in 1 liter of solution is equal to 1803.2 grams. Means its weight is more compared to its volume because it is heavy in nature. It has more specific gravity. Step 2. Calculate the number of moles in 1803.2 grams of H2SO4 by using the formula. Now what we are doing? When you are preparing any normal or molar solutions, you must be knowing their number of moles present in 1 liter of solution and we can calculate it only by the mass. That is why we have calculated the mass of H2SO4 in 1 liter. Now we are calculating number of moles which is present in that mass of H2SO4 by following formula. Number of moles can be calculated by this formula, given weight divided by molecular weight. Here given weight means the weight which we are using. Now we have weight of 1803.2 grams and molecular weight we have to calculate that, which is 98. After dividing, we get the value of 18.4 moles. What does it mean? 1 liter of H2SO4, concentrated H2SO4 which has strength of 98%, it has weight of 1803.2 grams and it has 18.4 moles. Means molarity of 98% H2SO4 is equal to number of moles present in 1 liter of solution, which is 18.4 moles. Hence, we can conclude that the molarity of 98% H2SO4 is equal to 18.4 molar. But we are calculating the normal solution. We can use this for calculation of normal solutions as well. And normality of H2SO4 is generally 2 times of its molarity. You can learn this. If molarity of any H2SO4 solution you are taking, its normality will be double of its molarity. Suppose you have 1 molar solution of H2SO4, then its normality will be 2 normal. Right? Let's calculate for normal solution. Normality of 98% H2SO4 is equal to the double of its molarity, means 36.8 normal approximately. This number 36.8 normal is very important. You should learn this number. You should always know this number because you do not calculate always when you are preparing the normal solution of H2SO4. You just need this number. What is the normality of that particular concentrated H2SO4? That is 36.8 normal. If you know this number, you can easily calculate the volume required to prepare different normal solutions. Now, molecular weight of H2SO4, we already know it is 98, but how to calculate it? Simply by adding the individual atoms' molecular masses. Here we are using the simple formula to add up all the masses and we get the value of 98 grams. For normal solution, we need the number of replaceable ions, means H plus ions in case of acids. Here it is 2. You can see in the H2SO4, I have highlighted the H by red color because it has value of 2. There are 2 H plus ions which are replaceable in H2SO4. Okay. Now, gram equivalent weight is very important for normal solutions. What is gram equivalent weight? It is molecular weight divided by the number of replaceable ions. Molecular weight, as we know, 98 grams, and number of replaceable ions is equal to 2. And put the values and we will get the value of equivalent weight, which is equal to 49 grams. And generally there is another equation, molecular weight is equal to 2 times of gram equivalent weight of H2SO4. That is why I have already told you normality is always 2 times of molarity. Hence, normality of H2SO4 is equal to 2 times of molarity. Everybody should know this formula. Now step 3. Prepare one normal H2SO4 by normality equation. Everybody knows the normality equation, which is N1V1 is equal to N2V2. Here N1V1 representing concentrated H2SO4 and N2V2 is for one normal H2SO4 which we want to prepare. And let's put the values. Here N1 means normality of concentrated H2SO4, which is 36.8 normal, which we have already calculated, and V1 is the volume which is required to be diluted with water to prepare one normal of solution of any volume, whatever volume you want. Suppose here we want to prepare 1000 ml of one normal solution from concentrated H2SO4, and normality is 1 normal, as I already said. After calculating, we get the V1 as 27.2 ml approximately. What does it mean? It means to prepare 1000 ml of one normal H2SO4 from concentrated H2SO4, only 27.2 ml of concentrated acid is diluted up to 1000 ml of water. Got it? Different normal solutions can be prepared by using the above equations by changing the value of required volume and normality of the required solution. For example, to prepare 1000 ml of 0.1 normal H2SO4. Earlier we have calculated for 1 normal. Now we are calculating for 0.1 normal. You can also change the volume. We have taken the volume as 1000 ml. You can change it to 200 ml, 500 ml, whatever you need. Let's again calculate for 0.1 normal H2SO4 by using the same equation and put the values of concentrated H2SO4 as 36.8 normal, and here N2 values are changing. Now we have N2 value as 0.1 normal and volume we are keeping the same. You can also change that depending upon your requirement. So V1 is equal to 2.72 ml approximately. Earlier it was 27.2 ml because we were preparing one normal. Now we are diluting it 10 times and volume is also reduced to 10 times. So to prepare 1000 ml of 0.1 normal H2SO4, only 2.7 ml of concentrated acid is diluted up to 1000 ml. So by using this simple equation, you can calculate all volumes for different normal solutions. If you want to prepare 500 ml, change the V2 as 500 ml. And if you want to prepare 0.5 normal solution, change N2 value as 0.5 normal. And you can prepare by using this equation again and again. You do not need to calculate the normality of concentrated H2SO4 again and again. Just remember it, it is 36.8 normal and put the values in this equation and calculate for any normal solution of H2SO4 from concentrated H2SO4. Or let's see, to prepare 100 ml of 0.1 normal H2SO4, only 0.27 ml of concentrated acid will be required to dilute 1000 ml with water. So, from above calculation, we know that 27.2 ml of H2SO4 in 1000 ml of water will make 1 normal H2SO4 solution. And similarly, 2.72 ml of H2SO4 in 1000 ml of water will make 0.1 normal H2SO4 solution. Or we can say that 1.36 ml of H2SO4 in 500 ml of water will make 0.1 normal H2SO4 solution.
इस वीडियो से जुड़ी कोई भी परेशानी हो तो आप हमें नीचे कमेंट में जरूर बताएं ताकि हम आपकी परेशानी को जल्द से जल्द दूर कर सकें। अगर आपको हमारी वीडियो पसंद आई हो तो इसे लाइक करें और ज्यादा से ज्यादा शेयर करें ताकि बाकी लोगों तक भी ये जानकारी पहुंच सके। हमारे चैनल को सब्सक्राइब करना बिल्कुल ना भूलें और हमारी वीडियोस को सबसे पहले देखने के लिए बेल आइकन को भी जरूर प्रेस करें। फिलहाल दीजिए इजाजत, टेक केयर, धन्यवाद।